Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to chemistry classes. Today we are going to discuss about a new chapter in chemistry, that is classification of elements and periodicity in properties. In this chapter we are going to study about periodic table and periodic properties. Periodic table is a systematic classification of elements which are occurring naturally and some man-made elements. First, let us study why classification of elements is required. Why periodic table was required? Actually, we have 118 elements in the nature. There are 118 elements. Out of these 118 elements, some of the elements are the naturally occurring elements. The few elements are synthesized elements or man-made elements. Nearly 90 elements are naturally occurring. Now, when there are many elements, their properties are different. So it is difficult to study the properties of each and every element, and it is difficult to understand the chemical properties of the different elements. So scientists felt that if these elements are placed in a systematic way, if they are placed in a table in a regular order, the study of the elements becomes easy. This thought led to the classification of elements, and this thought itself led to the formulation of the periodic table. So why periodic table is given? Periodic table is formulated in order to organize the elements in a systematic way, in order to keep the elements in a systematic way so that their physical and chemical properties can be studied easily. So, the different scientists, they worked on the formulation of the periodic table. Actually, need of periodic table is placing elements in systematic way to study their physical and chemical properties. So this is actually the significance or need of the periodic table. Now, different scientists worked on the classification of periodic table, and they gave some periodic tables, like how the periodic table is formulated. So let's now study about genesis of periodic table. Here we are going to study about work of different scientists to formulate the periodic table. The first one who worked to classify the elements in a systematic way is Johann Daubenreiner. Johann Daubenreiner placed 3 elements which have similarity in properties in the increasing order of their atomic weights, and that periodic table is called as Dobereiner's triad. So now we are studying about Dobereiner's triad. This Dobereiner's triad is given by scientist Johann Dobereiner. What Johann Dobereiner did? He placed 3 elements with similar properties in the increasing order of their atomic weights. So element with low atomic weight is kept first. Element with higher atomic weight is kept at the end. So what he did is, he placed 3 elements in the increasing order of their atomic weights. Now, the speciality of this Dobereiner's periodic table or Dobereiner's triad is, the middle element had the atomic weight which is average of the 2 elements which are on either side of it. So middle element has atomic average of atomic weights of other 2. This is the speciality of the Dobereiner's periodic table. Now, let's consider the Dobereiner's periodic table. He gave 3 triads, that is lithium, sodium and potassium. This is the first triad given. Lithium atomic weight, if I mention, it is 7. Lithium is 7, sodium 23, potassium 39. Look at here, sodium atomic weight is 23. Sodium atomic weight is 23, which is the average of 7 and 39. Let's add atomic weights of lithium and potassium. Let's take average. So 7 plus 39 is equal to 23. Actually it is 7 plus 39 is 46. 46 divided by 2 is 23. Look at here. We have 3 elements. Lithium Li, sodium Na, potassium K. Their atomic weights are in the increasing order. So he arranged the elements with similar properties in the increasing order of the atomic weights. Middle element has the average atomic weight of other 2. This is one Dobereiner triad. Another Dobereiner triad is the calcium, strontium, barium. Calcium, strontium, barium. Calcium atomic weight is 40, barium atomic weight is 137, strontium atomic weight is 88. The 88 is average of 40 plus 137. Strontium atomic weight is average atomic weight of calcium and barium. So he kept 3 elements with similar properties in the increasing order of the atomic weights. Middle element had atomic weight which is average of the atomic weights of first element and the last element. One more triad given by him is chlorine, bromine, iodine. Chlorine, bromine, iodine. Chlorine atomic weight is 35.5. Bromine atomic weight is 80. Iodine atomic weight is 127. Middle element here is bromine, whose atomic weight is 80, which is average of 35.5 and 127. So he gave 3 triads. First one is lithium, sodium, potassium. Second one calcium, strontium, barium. Third one chlorine, bromine, iodine. Everywhere you can find the elements are arranged in the increasing order of the atomic weights, and middle element has atomic weight which is average atomic weight of other two. But this Dobryna's triad had limited applications. Dobryna's triad is applicable for only few elements. Hence, this Dobryna's triad failed. Dobryna's triad is applicable for limited elements only. That's why Dobryna's triad failed. For all the elements what we have, this concept cannot be applied. So, speciality of Dobryna triad is here 3 elements. Triad, three. Triad means 3. 3 elements are arranged in the increasing order of the atomic weights, and middle element has atomic weight as average of the other two, but this periodic table failed because it can be applied only for limited elements. After this, another scientist, that is A.V. Chankortais, arranged the elements in the cylindrical form, but that too had limited application, hence failed. After that, one more scientist, that is Newlands, John Newlands, gave the periodic table. So now let us study the periodic table given by Newlands, which is called as Newlands law of octaves. So let's now study about Newlands periodic table. This Newlands periodic table is dependent on Newlands law of octaves. This Newlands law of octaves proposed by scientist John Newlands. What this Newlands did? He arranged the elements in the increasing order of atomic weights, and he found that first element and 8th element have properties similar to each other. Actually, this Newlands periodic table depends upon law of octaves. Octaves means this placement depends upon the octave music, that is modern music. Here in this periodic table, first element and 8th element had similarities in properties. The elements he arranged are from lithium. So he arranged the elements in this way. Let me consider lithium. After lithium, beryllium comes, then comes boron, B, then comes carbon, then comes nitrogen, oxygen, then comes fluorine. Here, first element, second, third, fourth, fifth, sixth, seventh. Then 8th element is sodium. After sodium, magnesium comes, then comes aluminium, then comes silicon, then comes phosphorus, then sulfur, then comes chlorine. After which, next element comes is potassium, and the next one which comes is calcium. See, so many elements he placed in his periodic table. He placed these elements in the increasing order of the atomic weights. So here elements are placed in the increasing order of atomic weights. That means the atomic weight of lithium is less than beryllium, than boron, than carbon, than nitrogen, than oxygen, than fluorine, than sodium, and so on. And the speciality of this periodic table is properties of first and eighth element are similar. Here in the periodic table, if you consider, lithium is the first element. For it, eighth element is sodium. For sodium, eighth element is potassium. You can count if you want. 1, 2, 3, 4, 5, 6, 7, 8. That means for lithium, eighth element is sodium. If you consider sodium as the first element, magnesium second, aluminium third, silicon fourth, phosphorus the fifth, sulfur sixth, chlorine seventh element, and potassium eighth element. That means for lithium, eighth element is sodium. For sodium, eighth element is potassium. These elements, lithium, sodium, potassium, have similar properties. Next, you can consider beryllium. If you consider beryllium as the first element, for it, eighth element is magnesium. For magnesium, eighth element is calcium. So, properties of beryllium, magnesium, calcium are similar. If you consider boron as a first element, for it aluminium is the eighth element. For carbon, eighth element is silicon. For nitrogen, eighth element is a phosphorus. For oxygen, eighth element is sulfur. For fluorine, eighth element is chlorine. So, first and eighth element had similar properties which are arranged in the increasing order of their atomic weights. But even this periodic table failed. Why it failed? Because it is applicable up to calcium, means it is also applicable for limited elements. That is why this periodic table also failed. So, we studied two periodic tables, Daubereyner's periodic table, where three elements were arranged in the increasing order of atomic weights. It is failed due to its limited applications. Newlands law of octaves, where first and eighth element had similarities in properties, but even this failed because it is applicable up to calcium, or you can say it has limited applications. After this, two scientists worked independently to propose a new periodic table. The two scientists who worked independently at the same time are Dmitri Mendeleev and one more is Lothar Meyer. These are the two more scientists who worked to formulate a periodic table. They worked at same time, but they worked independently. What Lothar Meyer studied? Lothar Meyer studied properties of elements like atomic volume, melting point, density, all these for the elements. Lothar Meyer studied properties like atomic volume, melting point, density, etc. Then he plotted a graph. The graph plotted is atomic volume versus atomic weight. He plotted a graph of atomic volume versus atomic weight, or any physical property versus atomic volume. What he found that elements with similar properties show similarity in graphs. That is, in the graph, the few elements occupied a peak of the graph. Like this, if you plot the graph, few elements occupy peak, few elements occupy crest. The elements which are at the peak had a similarity in properties. That is, in the graph, whichever elements occupied similar position had a similarity in properties. That is what he found. But at the same time, another scientist, Dmitri Mendeleev, was also working. When he was working on periodic table, number of elements available were less. Only 63 elements were available when Mendeleev worked for the formulation of the periodic table. What Mendeleev did is, he studied properties of every element and he noted it, and then he arranged elements with similar properties together. Actually, what Dmitri Mendeleev made it, he made 63 cards, because at that time only 63 elements were present, and on each card he wrote the name of the element, he wrote the atomic weight, he wrote the properties. After that, he segregated the cards. He placed the cards together where properties of the elements were found together. For few elements, properties were similar. Such elements were placed together, their cards were placed together. And based on this, he formulated a periodic table. That periodic table is Mendeleev's periodic table, which is basically dependent on the atomic weight. In Mendeleev's periodic table, the elements are placed in the increasing order of their atomic weights. Mendeleev's periodic table is dependent on a periodic law. The periodic law given by Mendeleev is called as Mendeleev's periodic law. What Mendeleev's periodic law says? According to Mendeleev's periodic law, properties of elements are periodic functions of their atomic weights. So what he says is, the properties of elements are periodic functions of their atomic weights. That means Mendeleev's periodic table is purely dependent on the atomic weights, where he placed the elements in the increasing order of their atomic weights. So Mendeleev's periodic table is arrangement of elements in the increasing order of their atomic weights. Arrangement of elements in increasing order of their atomic weights. When he formulated periodic table, he had only 63 elements. Those 63 elements he arranged in the increasing order of their atomic weights. Elements were arranged in the form of vertical columns and horizontal rows. In his periodic table, there were vertical columns. These vertical columns are called as families, and horizontal rows. The horizontal rows were called as series. In his periodic table, the elements with similar properties were in the same vertical column. So, elements with similar properties are placed in same vertical column. So, if you look at the vertical column, you will find the elements with the similarity in properties. Mendeleev placed the 63 elements what he had. At the same time, he predicted that there are some undiscovered elements for which he kept the space in his periodic table. So, for undiscovered elements, he left space. Say for example, after aluminium, he left one gap. After silicon, he left one gap. The element after aluminium, he kept one gap. Even after silicon, he kept one gap. This element which comes after aluminium, he named it as Ica aluminium. Ica means after. So this element is after aluminium. He kept one space after silicon and he named it as Ica silicon. Now these Ica silicon and Ica aluminium are discovered. This Ica aluminium is actually gallium. Ica silicon is actually germanium. Now they are discovered. But before their discovery itself, Mendeleev predicted that there are some elements which may have similarity in properties for the elements already present. So he kept space and he gave the names this way. Ica aluminium is now known as gallium. Ica silicon is now known as germanium. Mendeleev, when he formulated periodic table, the 63 elements were present. Now there are many. Now there are 118 elements. And now the periodic table what we have is not according to the increasing order of atomic weights. It is according to increasing order of atomic numbers. Mendeleev's periodic table is purely based on increasing order of atomic weights, but still he placed some elements, even though they have low atomic weights, he placed them prior than the atomic weights which are low for the few elements. I mean, even though elements have higher atomic weights, in the periodic table he placed them first, thinking that there may be some error in the measurement of their atomic weights. Actually, Mendeleev's periodic table is arranged in the increasing order of atomic weights, but in some places you will find the element with higher atomic weight is kept first, element with lower atomic weight is kept later. Such adjustments were made in Mendeleev's periodic table. I told you, actually, Lothar-Meyer and Mendeleev worked independently simultaneously. But Lothar-Meyer's work was not published. Mendeleev's work was published and it is recognized and it is called as Mendeleev's periodic table. So this is about Mendeleev's periodic table and genesis of the periodic table. In the coming class, we will be learning about modern periodic table, the arrangement of the elements in a systematic order, and periodicity in properties. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.